Students, we are given this question to evaluate integral 0 to 1 x raised to the power 5 times 1 negative x squared raised to the power 5 times dx. Now for this, foremost we would have to take x to be equal to some sine theta. You differentiate this, you get cos theta times d theta. Now when x is equal to 0, theta will also be equal to 0, and when x is equal to 1, theta will be equal to pi over 2, because if x is equal to 1, the only value by which sine theta can be equal to 1 is sine 90. So that's why I have theta to be equal to pi over 2. Okay, so making the substitutions in the question, in the place of x I would have to substitute sine theta raised to the power 5. This is 1 negative sine squared theta raised to the power 5. In the place of dx, it's going to be cos theta times d theta. Rewriting this would give us sine raised to the power 5 theta. 1 negative cos sine squared theta is going to be cos squared theta raised to the power 5 times cos theta times d theta. Now this is again rewritten as cos squared theta raised to the power 5 is going to be cos 10 theta. There is also a cos theta here, so rewrite that. Now this is rewritten as sine raised to the power 5 theta times cos 10 theta times cos theta will give you cos raised to the power 11 theta times d theta. Now my m is 5 and my n is 11, and both are odd. Okay, so the reduction formula, of course you have to place the limits. The limits are 0 to pi over 2, 0 to pi over 2, 0 to pi over 2, and 0 to pi over 2. Now there is a reduction formula which we know. We can just start off by saying we know that when m is odd and n is odd, the reduction formula is given to be as integral 0 to pi over 2 sine raised to the power m theta times cos raised to the power n theta times d theta is equal to n negative 1 divided by m positive n times n negative 3 divided by m positive n negative 2 times n negative 5 divided by m positive n negative 4. It goes on. Okay, so the last term, okay, that you will encounter is 1 over m positive 1. So this is the term that you will have to meet with. Of course the previous term would be 2 over m positive 3. So as said before, my value of m is 5, the value of n is 11. So let us go on by substituting the values for n and m. So n negative 1, that's going to be 11 negative 1 divided by m positive n. That's going to be 5 positive 11, place it in parentheses. Then 11 negative 3 divided by 5 positive 11 negative 2 times 11 negative 5 divided by 5 positive 11 negative 4 times 11 negative 7 divided by 5 positive 11 negative 6, 11 negative 9 divided by 5 positive 11 negative 8. Now 11 negative 9 will give you 2. So you have reached the second last element. Now you cannot proceed by placing 11 negative 11. That would become 0. So what you got to do is you have to place 1 there divided by, this is actually 1 over m positive 1. Okay, so in this case m positive 1, this the last term, the value of m is going to be 5, so you add 1 to that. So this is the penultimate term, so this is the last term. Okay, so remember this formula and make the substitution. So rewriting this, 11 negative 1 will give me 10, 5 positive 11 will give me 16, 11 negative 3, that would give me 8, and this one is going to be 11 positive 5, 16 negative 2, so 16 negative 2 will give me 14, and this one 11 negative 5, that one would give me 6, divided by 12, following it up with 11 negative 7, that's going to be 4, divided by 10, and then 2 divided by 8, and then 1 divided by 6. So this is what you have got. So this is rewritten as cancel 10 with 10, cancel 6 with 6, cancel 8 with 8. So you got 4 times 2 divided by 16 times 14 times 12. So 4 divides here 4 times, 2 divides here 2 times, so you got 1 over 2 times 14 times 12, which is equal to, you got 14 times 2 is going to be 28 times 12, 8 times 2 16, 2 times 2 4, 5, 8 ones are 8, 2, 6, 13, 1. So you're going to get 1 over 336 units. Okay, that is the final answer for the question.